All right, so we've got a sense for the electromagnetic spectrum. What we need to do is understand how light interacts with materials. And so to do that, we need to understand materials and we need to understand the atom. Okay, so what we're going to do is we're going to start with just a simple depiction of the atom to get some of the structure out of the way here. And as I think that you probably know, we've got a nucleus, a central nucleus with in it protons and neutrons. All right, that's where most of the mass really of the atom comes from. And then we have these orbiting electrons. Okay, and they have a negative charge, negative fundamental charge. And what I'd like to take a look at here is if, say, we put into this thing a photon of energy, E equal to hc over lambda, like we discussed with the electromagnetic spectrum. Well, if that photon has enough energy, it can cause an atom to be excited. So the atom will come up to a elevated energy. And I should also indicate here how we're going to refer to these distances. And in fact, the fact that these distances are well defined at this point with this model, with the so-called Bohr model of the atom, which is useful to get the conversation started. So what I've indicated here is there's these numbers, n equals 1, n equals 2, and those correspond to these shells where the electron can exist, and it's quantized. The energy is quantized. That means it can't exist at n equals 1.5. So the electron could be promoted up to n equals 2 or not. And if the photon energy is not sufficient to make this transition, then the electron won't be promoted and the photon goes through. But the other piece of the story is, we'll say a moment in time later, okay, later on in the same story, I was trying to be funny there. I guess that wasn't. Anyway, later, just a moment later, the electron will drop back down. See, I said later because I don't want you to think that there's 4 electrons here. This is actually just the same electron. It started here, it was promoted up, and now later I'm talking about it coming back down. So it'll drop back down, and when that happens, another photon will be emitted with exactly the same energy as the photon that caused the excitation, because the transitions are quantized. You can't go part way. Alrighty, so that is a quick look at the atom and the Bohr model of the atom. And what we'll look at next is that there's some insufficiencies in this model, in the fine structure of the atom. The quantization is actually a little bit more specific than this. There's finer energy structure, and in fact, we don't have these well-defined distances, but we'll look at that in the next video. Thanks.